You're welcome once again to New Focus Approach to Mathematics Basic 8. This is the revised edition, and in this video, we are looking at bearings. Bearings. This lesson can be found in page 235. Now, in Basic 7, we started the concept of bearings, and we are continuing in this particular year, that is year 8. Now, in Basic 7, we learned that a bearing simply means direction, giving magnitude and direction from one place to another. Let's say I'm located at this point here. Let me call the place A. And I'm supposed to move to this particular point here. Let's call the place B. Now, what is the magnitude? That's what is the distance from A to B, and what is the bearing of A from B or B from A? Now, if I want to know bearing of A from B, then it means I must locate my cardinal point at point B, where I have my north, my south, my west, and my east. And I'm to travel to point A. What direction am I going to use from point B to point A? That's what it means by saying the bearing of A, but from B. So from the north pole of B, I'll go clockwise. That's what we learned, that bearings is taken from the north pole clockwise direction. And so if I know the angle here, I know that from the north to the east is 90, and from east to south is 90, making 180. So if I know the angle here, I could add the two angles, that is the 180 plus the theta, to give me the bearing of A from B. And if I'm going the other way around, B also from A, in that case, I'm going to be reading my bearing from point A, and this is my north pole. So I'm going to go clockwise, just 110, then I'll get to the line. And so whatever angle this is, that becomes the bearing of B from A. This is what we learned in book 7. Right, now here we want to do more graphical representation of bearings. Let's take a question and see. This is open board writing space where you can do interactive work, and it's a free software that teachers can take advantage and use it to teach online. Open board. If you type open board, you can easily download it and then install. It's free. Now here we want to express the vector AB68 graphically, and then find the length, and then also find the bearing of B from A. So first of all, I'll draw my line representing the vector AB. So let's say from the point A here, I'm supposed to move 6 on the x-axis, then 8 on the y-axis, so it will get me to this point. Okay, so this is the vector I will call vector 6, okay, 8. And this is the point A and the point B. Right, and the question says I should find the magnitude, and the magnitude I can calculate it or I can measure with my ruler. Maybe let's do the two and see whether we get the same results. So let's pull our ruler from here so we can measure the distance. Okay, so let me position it well. So let me position it. Okay, so you can see here that the dimension of that line is 10 centimeters for now, right? 10 centimeters. So you can see that, right? Good. Now let's also do the calculation and see. Now we all know how to find the magnitude of a vector. We use the formula s squared, the x component squared plus the y component squared. Now our x component squared will be 36, and then the y, which is 8 squared, is 64. Now if you simplify this, we have 100 here, and when we simplify further, square root of 100 is going to give us just 10, right? So we get our 10 centimeters. Okay, so it means that our ruler measurement and that of the calculated value is the same. You get it? So that means what you've done is right. Now the next question says we should find the bearing the bearing of B from A. So B from A, that means we want to locate the point B. So the bearing of B from A, now we know our point B here and our point A here, right? So the bearing of B from A, that means we are locating B by reading from A, and the north pole of A is here. So we go clockwise until we get the line. Then that angle becomes our bearing. So we want to find this angle here. And we can use protractor to measure that. Okay, so let's introduce our protractor and then put the pin. Okay, so we need to go this way so that we can measure from the north pole up to the line. So we will measure. So let me just clean this a bit, and then we measure. So let me zoom. Okay, so we can see what. Now we are measuring from 0 here clockwise. Okay, 0 here clockwise. So we have 10, 20, 30. Now 30, let's see, the angle will be 30. So we can say 30, 35 should be this line. So 36. So let's say 36. So our angle will be 36 degrees, and we'll write it as this. So our distance is 10 centimeters, and then our what do you call it, bearing is 3,6. So this is the magnitude bearing form of the vector that was given to us. Let's take one more example and see how we can represent a vector using graph, at the same time find the bearing of that. All right, so with this question, we say express the vector PQ, which is -6, -8, graphically, and find the length and then that of the bearing of Q from P. So first of all, we'll draw our line. On the x-axis, we are going -6. Okay, -6 is somewhere here, and positive and -8 as well. So that is our vector -6, -8. So that is P and then Q. Okay, vector PQ. So it goes like this, PQ. So that's our vector. Now we have to measure the length PQ. Of course, since we have -6 and -8, it's obvious that the distance is going to still remain 10 centimeters for us, because the same thing is what we did for the previous one. But then to find the angle, we need to know the angle right from the north pole of the, okay, fine. The question says we should find the bearing of Q from P. So from P, we want to find from P, so Q from P. So from the north pole of P, we'll come right up to the line that link the 2 points. And so we know that between the north pole and this is 90. Between the 90 and this line also is another 90, making 180. So all we need is the small angle here, so that we can know that if you know that angle, we can add it up to the 180 to give us the bearing. So with the help of our protractor, we can now measure. We can now measure that small angle. So let's do that. So let me rotate. Okay, so we can take it from here. So reading from 0 here up to the line here, when I open it up, you can see from 0, 10, 20, 30. Again, we have 35, 36. Okay, 36. Yeah, or 37. Let me make it 37. So 37 degrees is the angle that we have small there. So 37. Then our bearing of Q from P will be this 37 degrees plus the 180 we have from North Pole up to the South Pole. And so when we put this together, we are going to have 217 degrees. So that is our bearing. So this vector PQ, which was given as -6, -8, can be represented in the magnitude bearing form as 10 centimeters and then 217 degrees. So that is the bearing form of that. I'm sure this has really helped you to understand how to represent vectors graphically using protractor to measure angles to get accurate dimensions or accurate direction. Thanks so much for watching.